a good time. So before we start describing big data, I just wanted to give you some idea of the kind of volumes of data that are being generated today. So if you look at this slide, there are 2 or 3 interesting things that I would like to focus your attention into. One is that we are now looking at moving forward into 2020 into zettabytes of data. And 1 zettabyte is a million gigabytes. If you look at the left bottom corner of this slide, 1 zettabyte is a million gigabytes. So we've come a long way from the time when even mainframes used to have megabytes of data storage. So one is this absolutely overwhelming volume of data. Now, if we look at a little bit of detail, the other interesting thing is that unlike before, organizations are not the main generators of data anymore. So out of the 35 zettabytes of data, only about a third of that will be generated by organizations, which means, organizational transactions, organizational storage systems, data that is generated out of ERPs and data that is generated out of CRM applications, that will contribute to only about 1/3 of the total data that is generated. 2/3 of the data that will be generated and will be used by organizations to make decisions is actually going to be generated outside of the organization. Yeah, so organizations using X, Y, and Z, I mean, okay, so if you look at organizations like, let's say, Walmart, okay, they have started using social media data, and the moment you get into social media and you start looking at data generated through Facebook and Twitter and let's say YouTube, you are getting into exabytes of data straight away. Okay, so an organization looks at the data that it is generating, and it always looked at that. But today it also has access to and the ability to analyze data that lies outside the organization, which is huge because that is being contributed to by both, by all of us, right? It's user-generated, crowdsourced data. So organizations like, Walmart, organizations, even governments, if you look at the Obama election, the second election of Obama, the Obama team looked at data outside the organization and social media data to design communication, to ask for to crowdsource money and all of that. So I can give you 3 or 4 quick examples of organizations, but governments as well as political parties are also using data which is lying on social media today. Okay, a company like GE would be using not only data generated by itself, it would also be using data generated in through social media, and it would also be using data generated through equipment. It has, most of the equipment are now progressively becoming smart equipment, and as we move to the era of Internet of Things, most of these equipment are going to get attached to the internet, and they are also going to generate massive volumes of data. And it's now up to the organizations to figure out which of this data is relevant to them, and then find ways of accessing and analyzing that data. Does that answer your question, Umesh? Thanks. So let's look a little more closely at this this particular slide. Although more than 70% of the data is going to be generated outside of organizations, enterprises will actually be managing and securitizing 80% of this data, because private smaller organizations or people like you and me don't have the don't have the technological capability of doing that, right? Yeah, I get your point, Umesh. This is when we come to concepts, the font size will be absolutely comfortable. These are slides which have been taken from sources where these are infographic size. So I don't bother about the font size. You'll be fine. Okay. Yeah. Right. So let's look at another interesting slide on data, because I think we need to get a feel of. Uh, Welcome, Rajiv. Can you hear us now? Yeah. So let's have a look at where all data is getting generated, and get a hold of some of these numbers. This is about a 1-year-old slide, so I'm sure that things would have changed and become even bigger. So we are, for example, generating 2.9 million emails every second, and we are looking at 20 hours of video being generated by YouTube every minute. If you look at the rest of it, I'm not going to take you through all of them. You can have a look. I mean, data processed by Google, 24 petabytes of data per day. There are 50 million tweets and increasing per day, and stuff like that. So every tweet, every like on Facebook, every comment, every even navigation through these sites is data, right? Because it gives us an understanding of consumer thinking, consumer behavior, trends, and stuff like that, right? And then let's look at what happens in an internet minute, because this is where all the action is, and this is the largest generator of data in any case. So look at some staggering figures. There are 277,000 logins every minute on Facebook, and 6 million Facebook views every minute, and there is 30 hours of video uploaded every minute, and 1.3 million video views on YouTube, and stuff like that. So now, although it's great that we have all this data, yeah, uh, yeah, good to have you with us, Rajiv. Yeah, so one is, it's good to have all this data, but the fact that we did not talk about analytics and we did not talk about big data till very recently is also because, remember one thing. Yeah, sure, we will share the presentation with you. Yeah, you got to keep track of one thing, that, organizations will spend money on analysis if the cost of that analysis is significantly lower than the benefit it gives them, right? So irrespective of the amount of data that you have, if you don't have, uh, to use a common word, a cheap way of accessing that data, a cheap way of operating on this data, and also a cheap way of storing that data, then organizations will not spend money on this. So today, technologies are available for easy access, easy operations and analysis, and easy storage of this data, which is why organizations are finding it beneficial to analyze large volumes of data and base their business decisions on that. And it's not just businesses, governments are using this data for better policing, for combating things like terrorism, for providing better health care. So this big data analytics is not just for, business profiteering. It also has a lot of social significance. I think we need to understand that as we move forward. That's right. So let's move. And another, Eric Schmidt, the CEO of Google, said that from the dawn of civilization until 2003, humankind generated 5 exabytes of data. Now it's 5 exabytes every 2 days, and the pace is accelerating. So if you have a look at this slide, and that itself is absolutely staggering, that the amount of data that we generated from the dawn of civilization till 2003 is the amount of data that we generate every 2 days now. And research tells us that we'll be generating this amount of data in every 2 hours in a couple of years. So there's absolutely no doubt that this is a data deluge, and that the amount of data that is going to be available to us is just going to keep increasing. So if you make data your career, I think you are picking the right path, because it's only going to go up. So what is big data? Now there are, because it's a new term, there are lots and lots of opinions about what big data is. One of the popular ones is that if you cannot use the existing RDBMS kind of technologies to manage data because the volume is so high, then it is big data, right? Uh, so either you leverage existing systems differently, or you actually have totally different systems to handle this data, because the existing systems are not capable of handling it. For example, it's difficult to imagine an RDBMS handling Facebook data. You can't really put Facebook data in rows and columns. So you have different ways of dealing with data like that, and that's what big data is all about. And these are the three V's. People are now getting into 4 and 5 V's, and we will discuss that when we come to it: volume, variety, and velocity. And each of these three V's have their own significance, and we will discuss that when we move forward in this discussion. At this point in time, you know that the volume is high. You know that there is variety because there are data of all kinds. You have text data, you have structured numerical data, you have uh, semi-structured data that comes out of equipment like RFID strips. So you have different kinds of data from you have video data coming out of CCTV cameras, and all of that can be analyzed for business decision making. And velocity is a concept where how quickly can you analyze this data and come back with insights, because some of this data can get obsolete very quickly. So do you have the technology in place to access, store, or not store, and do streaming analysis of the data and come back with a useful insight that I can use, for example, location-based selling? I mean, there is no point in catching somebody when he's past the store that you want him to enter. So you need to send him a message informing him of a discount in a store that he's approaching, and you have to do that in near real time for that message to be topical and useful. The moment once he crosses the store and he's half an hour away from that store, the message has absolutely no value, right? So we call that the obsolescence of data. So some data becomes obsolete very quickly. So you need velocity to be able to use that data effectively. And then it's there is much more of qualitative and unstructured data than there is structured data, because as you know that the amount of interaction and engagement that we have on social media is far more than the data that organizations generate out of their transactions. And secondly, this also provides a massive challenge, because it's far more difficult to analyze unstructured data, text data, than it is to analyze structured data. So the nirvana of big data is getting a system that can do text analysis and that can do sentiment analysis, because that's what organizations are looking at, and that's where all the research is happening, and that's where all the action is. Right, if there are any questions, this is a good time, or we will move to the next slide. Yeah, okay. Anyway, just feel free to ask your questions anytime you want to. Yes. Right, so what does big data do for us? There are just 2 or 3 examples here, and I'll give you more of them. The first one is understanding target customers better. Now, the objective of every organization is, can I get a hold on consumer behavior? can I get mind space of the consumer and can I put my brand in that mind space? So one of the efficient ways to do that is to first understand who your customers are. So, for example, if you give an advertisement in a newspaper, for example, let's say I'm a business school and I give an advertisement in a newspaper on, why people should join my business school or the admission application for my business school. Now, 90, maybe 98% of the people who are reading that newspaper are not interested in an advertisement for application to a business school. However, when I negotiate the rates for that advertisement with my newspaper supply, the newspaper or the business house, they will talk about circulation rates and readership rates and all of that. So what I'm doing in effect is I'm broadcasting that message and paying for the fact that this newspaper is read by, let's say, 5 million people, whereas out of those 5 million people, only about 50,000 may be interested in that advertisement. So that is problem number one. Problem number two is, unless I give a series of advertisements, and that becomes very expensive, the target audience could just miss that ad because they didn't look at the newspaper on that particular day, right? So this is a very inefficient way of reaching out to your target customers. So if I can use big data to understand who really my customers are, and if I can find ways of reaching those customers, then my marketing expenses for reaching out to my customers are much lower, both in terms of time taken as well as money spent. And my message can be customized better because I know what are my customers really looking for, right? So big data can help us do that. There are various technologies. You will come to know them as you move forward in this course. Uh, uh, Broadly speaking, we use data mining and we use certain techniques within data mining to better target and better understand. We call it customer segmentation. So that's what we do, right? And then second is cutting down in expenditures in various sectors. So I saw when you people were introducing yourselves, I think it was Ravi who's part of the supply chain. I think correct me if I'm wrong. Now supply chain. So there are two things why companies managers get paid. The two things that managers get paid for are we helping the company generate more revenue, and stroke are we helping the company to reduce costs? If I make a decision in an organization that neither helps in increasing its revenue nor helps in reducing its cost, then that decision is not worth taking, right? So if I can use big data analytics, if we look at the first 2 points, in the first point, I should be able to increase my revenue because I know my customers better and I can target them better. The second point, I can reduce my cost, right? So there is something called supply chain analytics, which looks at all the components of the cost that are part of supply chain. And can I use big data analytics to forecast better? So that if I can forecast demand better, I can actually have a better supply chain system in place. I can handle my inventory better. I don't have excess inventory, in which case I'm not kind of blocking my cash, and I don't run out of inventory, in which case customers should not come and not find the thing that they're looking for. So cutting down expenditure without losing out on customer service is one of the big contributions that big data analytics can make. And increase in operating margins in different sectors. This is kind of like a function of either increasing revenues or reducing costs or both. The third thing that analytics does is it helps organizations reduce their risk. And reducing risk is important because if you can reduce risk, then you can maximize profits in the long term. Because even if I'm making good profits now, if my company or my organization is vulnerable to external or internal risks, then in the near term I may make money, but as I move forward, I could actually be in trouble. So can big data analytics help me understand that risk, measure that risk, and also help minimize and manage that risk better. So these are some of the things that organizations are perpetually looking for, and these are some of the things that big data can help organizations achieve. Right? If you have any questions, I'll keep asking you, and feel free to come in whenever you want to. Right. Let's move to the next slide. So, right analysis of available data can transform major business processes. So now I'll take a couple of minutes to also talk about what people call data-driven disaster. Because if the organizations start moving on the path of big data analytics, then they become more and more dependent on data and the analysis of data to make decisions, right? Now, once they start doing that, it becomes really important to ensure that you're looking at the right data, that the data that you have is the correct data, that the techniques you are using for analysis of data are the right techniques, and that the interpretations you are making out of that analysis are the correct interpretations, and that the final decision that you are making on the basis of that analysis is the right decision for the company. Because if you go wrong in any of these 4 or 5 components, then you are actually vulnerable to more risk than you were before you started using big data. I hope you all agree with that, isn't it? It's like IT. Till the time organizations were not dependent on IT, Devendra, it's not. In fact, I'm really glad that you made that statement. Uh, and big data analytics has IT structure as its background, but everything does not depend on that. For example, if let's talk about a company that says that I'm losing revenue. Now, IT structure cannot help it understand why it's losing revenue, right? So you then need to ask certain questions that let's say if you're a retail store, is your footfall falling, or are people coming into the store but not buying, or not buying as much as they used to, right? So which is the right metric that I need to look at to do my analysis? And if I go wrong there, then I would be looking for something else and trying to make decisions on something totally different. The IT structure supports whatever processes I want it to support, but it's the human mind, it's the analytics team, it's the data scientists along with the business people who will decide what is the data we should look at, what are the metrics that we should concentrate on, and what is the kind of analysis we should do. Then we know that technology is available to look at the data that I want to look at, to measure what I want to measure, to process what I want to process. Is that okay, Devendra? Does that kind of, you half convinced? Okay, great. So now the other important part of this whole thing is we have a term called, like all areas, analytics has also its own jargon. And there is a 2-word jargon which will become very important, will become part of your life if you move forward on this path, is actionable insight. Okay, I think we all know that we are using to get insights about our business, right? But it's very important to understand that I want actionable insight. I want an insight on which I can take action. Which means I can make a decision, I can change a process or change the layout of the store, or make a change to the way I talk to my customers who want mutual funds. I need to be able to act on the insight that I'm getting to be able to make an improvement in the business, because I'm going to spend a lot of money, a lot of management time to start my big data analytics process in my organization. But at the end of the day, if the insights and the knowledge I get about my business are not actionable by me, then that particular insight is of no use, right? So every time when we sit and we do a little bit of consulting as well as a business school, every time we sit down with the customers, we get into this debate that why are we looking for this, and if we get certain insights, will we be able to take action on them or not, right? So as we move forward, I will share some examples of both actionable and non-actionable insights, and I think it will become more clear. So let's look at this. I'm just going to first go through all of these. Basically, what this slide is trying to say is that I can make use of data and analysis of data in pretty much every function of the organization. Okay. Now that brings us to another question, which is, why I'm discussing these questions with you is because I looked at all your profiles and you're all working professionals. So I think that the business side of things would be very relevant for you. As an organization, you may not be, you want to start your data analytics journey, and you have, 50 functions that that are important for you in the organization. But you cannot start using analytics for all those 50 functions, right? So as an organization, again, it's the management of the organization and their understanding of the business that will determine that out of these, which are the first one or two areas that we focus on when we start using analytics. These are called the levers. Which is the lever that I should press, which will give me the maximum return. So, for example, if you are a retail chain, maybe supply looks like a great lever to press, because if I can bring down my costs by even 5% in my supply chain for somebody like a Tesco or a Walmart, I straight away increase my margin by 5% because it's a straight cost saving for me. Whereas for another company like a Rolex, maybe, it's not about supply chain because prices are not so important for them. It's probably reaching out to the right people with the right message. Okay, so depending on what business you are in, what are the kind of customers you have, and what are the kind of processes you have in your organization, as part of the management of your organization, you need to select those one or two processes where you want to start using analytics. As you start getting results, you then move from one function to the other and to the next one. So let's look at these quickly. Let's look at procurement. Procurement has several aspects to it. One is, raw material. Am I buying the right raw material? Am I buying it from the right people? Do I have a proper handle on who are my vendors who are performing well, who are the vendors who are not performing well? Can I do something to make the performance of my vendors better? Can I collaborate better with them? So procurement, depending on whether it's critical procurement or simply, repair maintenance procurement, we can use analytics. We can use deep analytics to improve both procurement processes as well as the quality of the material that we procure. Product development, with all this, hype about innovation and entrepreneurship and all that, product development is going to become more and more important. So, and product development is expensive, right? So, can I use big data analytics to tell me at an early stage in my product development life cycle whether I am on the right path or not? Can I do crowdsourcing to help me in product development? And large organizations have started doing that. Can I collaborate with my vendors in product development? There are IT systems that already do that. Can I use analytics to improve the way I collaborate to do product development? There is a completely entirely different set of analytics under the umbrella of manufacturing analytics, which includes autonomic systems. It includes systems for preventive maintenance, scheduling, because large manufacturing organizations it includes to some extent factory management, warehouse management, factory planning. So there are lots and lots of and all machines today, or most of the machines today, are spewing out data. They are smart machines. So all that data is put into the black box. Algorithms are run so that we improve our manufacturing processes and therefore bring out better quality products at lower cost and on schedule. Okay, distribution again part of supply chain in some sense. Yeah, let's look at marketing and price management a little bit. In marketing, we have the marketing mix, which are the 4 P's of marketing: product, price, promotion, and place. And analytics can be used for each of these 4. So what we say is, can I use analytics to optimize my marketing mix? That means I have the right product at the right price, with the right message, and being sold at the right place. So let's look at, there is a Kirana store and also there is Flipkart. So where should I sell my product from? Should my product have the same price at both the places? If I'm part of a huge retail store, should I reduce my price by 10 paise or 15 paise or 12 paise on a Wednesday afternoon to optimize my takeaway, right? And people are working on these. So if you go to a large global retail store, prices change dynamically through the day based on the kind of data that is flowing into the system, and that's all done automatically. Yeah. Merchandising, what should I bring to the store? What should be my inventory? Should I carry yellow shirts or green shirts, or how many of them should I carry? And of course, at what price? So there's pricing analytics, there's merchandising analytics, sales automation, and then store operations, again part of supply chain. An interesting thing is, human resources. So pretty large human resource analytics practice now in a lot of organizations. Large IT companies are getting into it, large banks are getting into it. So all those kind of organizations that have large teams are getting into human resources analytics. They're looking at things like attrition. You take a person on board, that's a cost. Then you train that person, it's a cost. The person stays for 1 year, 1.5 years, 2 years, starts contributing to the organization and then leaves. So can I use analytics to improve my selection so that I can reduce attrition? So a company like, let's say, an Infosys would look at campus recruitment over the last 20 years and try and see patterns, which are the colleges from where students have stayed longer, which are the, maybe demographics, family income people who have stayed longer with Infosys, which geographical area have people, stuck on longer with Infosys. So can I use all this data? And sometimes data throws up amazing insights. And suddenly you say that with this huge ocean of data, I could never have done it on my own. But I did analytics, and now I find that if I go to these 40 colleges and select these kind of people, I can reduce my attrition by 5% or 2%, and that's a huge saving for the organization, right? So that's the kind of thing that analytics can help you do. Any questions? Rather quiet class. Are you guys with me, or are you have I lost you? Okay, thanks. Good to hear that. Right. Any comments, observations? You guys have to give me time to breathe, right? Okay. So if there's any problem with understanding, just let me know. Okay. Thank you. Okay. Thanks. Thanks. Let me move forward then. Okay. So let's look at sources of big data. So this becomes more objective now. So I have basically 3 types of data. One is social data, which is unstructured data. Second is machine data, which is semi-structured data. And the third is transactional data, which is structured data. So all of us on this course are very happy with transactional data because it comes in neatly defined rows and columns. We've lived with that all our lives. So there are fields as columns, and there are items as rows. Everything in good, nice numbers, easy to operate on, easy to put on an Excel sheet and do analysis, right? And it's not that this data is not important. It's very significant. And to our surprise, when we did a couple of consulting jobs, uh, pretty large organizations in India are not even using buying. I didn't get that, Umesh. Buying pattern as in? Yeah, I'm not sure I understand your question, but are you saying that uh, why is Facebook data important? Is that your broad question? Uh, this is yeah. That's okay. All right. Okay, so you are looking at the second column, first row. Uh, Provides an insight to companies about consumer behavior and buying patterns. Yeah. Okay. Right. So yeah. So let me try and explain that to you. What happens? How were we looking at buying patterns before this? There were two or three sources of information for that. One is your invoices. So if you go to stores and you buy stuff, there is an invoice. You may use your credit card, and so if you do a detailed analysis of invoices, then you know what kind of things people buy together. If you buy A, do you also buy B usually, and stuff like that. And what is an average ticket number when you get into a large store? How much money do you spend on average, and all of that, right? So we were looking at invoice data. We were also doing market research, and we still do that. So we would design questionnaires which are robust and valid, all the statistical things that go with questionnaires, and we would ask people questions about what do they look for when they buy, how do they how do they shop, and what is in their mind when they pick one thing over the other, and stuff like that. Now what has happened is, we call this self-reported surveys, which means we are depending on the customer's answers that the customer is giving, knowing the fact that this is a questionnaire and they are being asked questions. So one is, you may not be interested in answering those questions and you may write whatever you feel like. The second is, you may want to write socially acceptable answers, right, which are not really who you are and what you are. However, when you are on Twitter and Facebook, you are kind of yourself. Okay, so you go and watch a film and you write about the film. You write about what you really think of the film. You buy something, you eat something, you take pictures of what you've eaten in a restaurant, and you talk about certain, maybe the flavor or the taste or the way the food was laid out. So you are giving a lot of information about who you are, what are the things that you like, what are the kind of things that you prefer, yeah. And if I aggregate this over large chunks of people, then I can get some patterns of, these are the kind of people who buy like this, who have these things that they like, that they consider. These are the kind of people who do this. And then I look at my product and I say, okay, these are the kind of guys I want to go for. And this is the message that will work with them. Okay, does that make sense? Okay, great. Yeah, so now let's look at transactional data. So I'll kind of come from transactional data and then work my way up to social data. Transactional data is really important because it if you store this data well, and if you analyze this data, you can get a lot of insights out of it. The sad part is a lot of Indian companies don't do that. Okay, or I shouldn't say that, but a couple of companies that we know, we work with don't really do that. So I don't think that just because we have social data, we should disregard transactional data. It's reliable data. It's actual, real world transactions that have happened. People have bought something at a particular price in a particular store. People have taken a loan at a particular interest rate. People have bought a mutual fund. They have deposited money in a savings account. Okay, so all of this are real, sound information. And if I have lots and lots of such information, I can put it to very good use, because I can find trends, I can find patterns, and I can come out with actionable insights. Okay, so it's very important to not lose sight of the transactional data. And in fact, smart companies start their analytics journey with transactional data. One, it's your own data. Two, it is real data. And three, it's easier to analyze. So your investments are lower and your returns are higher. Okay, so moving, and if transactional data is huge, and you look at a, let's say, a Walmart, I mean, their transactional data would be absolutely massive. You can't analyze that on an Excel sheet, right? So you have to go to big data, technologies like Hadoop to analyze that. So your big data analytics will come in even with transactional data, and that analysis can throw up a lot of insights, right? Then we move to machine data, and I think the future kind of belongs to machine data because of the Internet of Things, right? We are already talking about wearable devices. You have the Google Watch. You're going to have, there's a project between Google and Levi's called the Jacquard project, where you'll be wearing smart jeans. So instead of wiping your mobile phone to get access to the internet, you will be wiping your the surface of your jeans while you're sitting and access the net. And so there will be a connectivity between your mobile phone and your so you can't even imagine the kind of things that are going to happen. So all this data from the machines is going to get connected to the net and is going to become analyzable, right? And then the navigation. When you get into a website, where all do you go? So you get into Flipkart, you spend 2 hours on Flipkart and buy nothing. The 2 hours that you spend on Flipkart is useful data for Flipkart, right? Because they know where you spend time, where which are the items you clicked on, you put them on the shopping cart, you took them back. All of this is information for them to understand how customers behave, and so all these, so there's an audit trail of how you navigated the particular site. Right? Yeah, yeah. And Umesh, glad you said that, because uh, a side effect of that is privacy issues. So Europe especially is yeah. Okay. Yeah, security as well as privacy, and there are two. Sometimes they are connected, because if you have no, if your privacy is compromised, then security, one is personal security also comes into play, and information security. Yes, there again, if we are going to go public, then we'll obviously have to have enough secure systems in place. So I guess IT will have to take care of its own problems. Yeah. So RFID is basically a radio frequency identity. I mean, so what you do there is that you have small strips that you can attach to objects, and these are smart strips. Okay, and these are attached to a central server. So if you put them on, let's say, boxes of televisions in a let's say a Samsung factory, then each television box would have an RFID strip attached to it, and so you would be able to kind of track its movement right till the time that it gets into the buyer's home and the box is thrown out. It can also be attached to your television itself, in which case till somebody breaks that television up and throws it away. Yeah, yeah. So RFID is used in many places. In fact, there was a move in the US at one time because of all the campus killings that were happening, both at school and college, that kids would be, uh, kind of, there would be RFID cards put on children. And then, of course, there was a furor from all the activists saying that you can't really. It's like branding animals. If you put cards or labels or RFID tags, the word is tag. On children. But if you did, you would be able to track the children. So what RFID helps you do is, one, of course, it helps you prevent theft or at least detect theft. It also helps you manage your warehouse better. Okay, it also helps you track behavior both in the warehouse and outside it. It gives you lots and lots of information about, for example, in a country like India, if you are, taking something from Bombay to Delhi, which are the places where the driver stops for food, which are the toll gates where it takes a lot of time, what is the average time that a truck should take, and all of that, because you have RFID tags attached everywhere, and they are smart, so they keep recording all that information, and so you can have you can store that information and use it for trend analysis. I am not sure of that. They have, I don't know if they need RFID tags because they are anyway connected to each other through software applications. So I'm not really sure of that, but I can check and get back to you. Okay. Yeah. Right. So yeah, let's move to machine data. So yeah. Yeah, I mean, you see, RFID as a technology is much broader, but an RFID tag is something very specific, right? So that's, I think, the difference between the two. Yeah. Now, so going back to this Internet of Things, we're going to have some horrendous number of, smart uh, equipment that is going to be connected to the internet, and all that data is going to get accessed. So can I use that data for analytics, right? And can I structure it? Easier to structure that than structure social data, but there are still issues with this. And then we come to this huge ocean of social data where you have Facebook, LinkedIn, Twitter, Flickr, Instagram, and all this, and people. So when we look at sources of data, we also look at pictures. Uh, and that's used with great effect in healthcare as well, but also socially. What are the kind of pictures that people are putting up, because it gives you insights into cultural changes, trends, what's working, what is not working, and stuff like that. Yeah. Right. Any more questions on this slide? Okay. So let's move to the next one. Oops. Yeah. So let's look at a small exercise just to test your understanding, and I'm sure it's easy for you to get that. A manufacturing company needs to improve its sales in the coming year, but does not know how. The company has sales transactions and customer databases. So this is all transactional data, structured data. How do you think the company can make use of this information? So I'm going to give you a few options here. Oops. I already gave you the answer. There's some problem with this. Yeah, the company can make use of sales data to study the consumer behavior and target them accordingly. The company can send coupons to all its customers. The company cannot do anything with the data that it has, and the company should launch a new product. So obviously the bottom three options don't make too much sense actually. So yeah. Um, the right answer happens to be a company can make use of sales data to study the consumer behavior and target the consumers accordingly, right? So sales data, as I said before, would have, you know, uh, not just what do customers buy, but in what quantity, at what times of the year, and what do they buy together. So if you look at, simple thing, if you go to Amazon, for example, and you search for books or something, and you click on one book, then automatically there is a there's on the screen, in the lower half of the screen, you get this message that people who bought this book also bought, you know, 1, 2, 3, 4, 5 other books. So when you look at analytics, you get into data mining. This is called the rule of association. That if people who buy milk also buy bread, and if you haven't if you have bought milk and not bought bread, can I sell you some bread? Right? So it's not just about volumes and what you are buying, but it's also about who are you, and if you are buying this, what else could you be buying? Okay. Yeah, so evolution of big data, I think even before the early 60s, I mean, if you look at, humankind has always been interested in data, and and we found ways of creating data and accessing data. But yeah, oops. Several tools, Ravi, to analyze big data. In fact, most of your course will be concentrated on that. Today is an introductory session. So and we make a difference between tools and techniques, right? So a technique could be, let's say, you know, data mining, and within data mining, let's say clustering, and a tool could be, let's say, a language like R, right? So first you have to decide what you want to do, and then you decide the technique that should take you there, and then you, depending on, your organization, you decide which tool you will use to do that. So a lot of people who do this course, analytics, they are kind of focused on the tools, but tool is perhaps the easiest thing to learn, right? It's because then it becomes simple technology, and do you know the code, and can you do it, right? So that's what it boils down to. But before you come to the tool, I think it's really important to understand the technique, and before you come to the technique, it's very important to understand the problem that you are trying to solve, right? Yeah, make sense? Okay, so yeah, so coming back to evolution of big data, as we started collecting more data and as we started getting better at technology, we automatically started demanding more from the data, and so when organizations became large and they started using technology and they started using data, they realized that if a company is spread all across the US and it has different views of data in different places in its factories and all, then it's difficult to make decisions based on that data. And that led to what we call the evolution of the centralized database, where all the data would reside in one central position. So that data would be the true data. There won't be any inconsistencies with the data. It would be reliable and accessible by all. So that was the first step in data analysis. And I'm having a little bit of problem with my, yeah. In the 90s, technology witnessed issues like with variety, email, documents, videos, leading to the emergence of non-SQL stores. So there is something, there is a technology called NoSQL, N small o SQL, which means not only SQL. Because if you don't have your data in rows and columns, then the structured query language that you and I are used to will not work there. So you have different techniques of accessing and getting and giving your query to that data and getting answers to it. And that's a pretty much a separate area of study. And large analytics, comprehensive analytics courses will have a subject on NoSQL as well, right? So it's becoming important. And so if you look at this, you look at three things: velocity, variety, and volume. There is so much volume that new storage and processing solutions have to be looked for, sought, and we do have these new storage and processing solutions in place today. So velocity, variety, and volume, these are the three main components of big data, and these are the three reasons why we have a whole new slew of technology for analyzing big data. Okay. Now this is a slide which my favorite slide actually, because it tells you how we have moved from megabytes to petabytes, and then moving on to exabytes and zettabytes in future. So if you look at the bottom left corner of the graph, we started with transactional data. ERP was a big thing in the 90s because it kind of connected the different parts of the company together electronically. So we had the finance, marketing, production, and HR and systems all connecting with each other, and we had records on purchasing, payment, and all of that. And we generated megabytes of data, which was analyzed, and the whole game of BI, business intelligence, kind of started here. Okay. Then what we did was we used technology to go outside the organization and also get my customers into my data factory, so to speak, right? So the moment I get into customer domain, typically for an organization, especially an FMCG kind of an organization, the number of customers is far more than the number of people in the organization. So let's look at somebody like a Unilever. The moment you get into customer bases and customer relationship management, the number of customers is so huge that your volume of data will go to gigabytes. Okay, yeah, I'll come to that, Umesh, as we move to A/B testing. I'll explain that to you. Okay, so CRM will have segmentation, customer details, customer history, and so the complexity increases as well as the volume. The next stage was when we went to the web. Okay, and when we went to the web, and this was the first avatar of the web, which was basically the read-only web. So large organizations had websites, there were some marketplaces, but you and I were basically audiences. We used to go to the website, get our information, maybe write an email, get a response, and that interaction. So that led to what is called the Web 1.0 revolution, and our volume increased to terabytes, and then we could use what we had on the web to do what is called A/B testing. Now, A/B testing is, let me give you an example. I think that will make it very clear. Let's say we look at a Walmart, okay? The Walmart or a Tesco or a Target, what they do is they send a lot of coupons to their customers. These coupons are basically discounts on some products on the store. The objective of this coupon is to get that particular person back to the store. And once you get into a large store, you not only buy the thing that is on discount, because you're in the store, you end up buying more things also, right? So that's where, you know, that's where that's why you want this customer to come to your store. So the problem is only the hit rate in couponing is only about 1 to 2 or maybe 3, 1 to 2 or maybe maximum 3%. That means if you send out 100 coupons, only two people will come to the store to use those coupons. So is there any way to increase my coupon hit rate? If I can take my coupon hit rate from 2% to 5%, that will give me huge increase in revenue, right? Now, so let's say I am a data scientist and I go to Walmart and I say that, I can use analytics to increase that couponing rate. So what Walmart would tell me to do is that, okay, fine, I'm going to give you, let's say, data on 5,000 of my customers or maybe 10,000 of my customers. Okay, you look at those 10,000 customers and you do whatever statistical analysis you want to do on this, and then you send coupons to those 10,000 customers, and we will see the success rate there. Okay, and if that success rate is good, then I will then apply it to the rest of my customer base. So this is called A/B testing, that I have a smaller group, which is my test group, on which I test my I do an experiment, and if that experiment turns out to be correct, then I apply it to the population, so to speak, in this place. Okay, so that is what is A/B testing, and when with the web, okay, kind of piloting using data. So this is basically So when you get into analytics, you will do a lot of POCs, proof of concepts, and one of the proof of concepts could be an A/B test. There could be other proof of concepts as well. Yeah. So that's what A/B testing is. And now we move to big data, which is why we are all here. And you look at the first word on the stack is sentiment. Which is so important. Because it's the dream of every marketeer to find out what is the customer thinking. What is the and look at brands, right? Brands are basically intangible. You pay for a pair of Nike shoes, not only for the comfort of the shoes, but also for the swoosh, right? So can I access and analyze and understand customer sentiment, right? And it's called sentiment analytics, which is based primarily on text analytics. Okay, and it's really interesting and really complex. And I'll give you another example of that because we've encountered that. Why is it so complex? So let's look at the word good. I think we all agree that good is a positive word. Okay, so let's say people are talking about my brand and they use the word good. So I should be happy about it, and if I do text analytics, it will straight away go into my positive box. Okay, now let's look at the use of the word good in 3 ways. So I've gone to a restaurant and I make a comment that the food here was very good. Okay, so that's a positive comment. Another comment I can make is, had they used a little less salt, the food in this restaurant would have been quite good. And a third statement, nothing this restaurant can do can ever make the food good here. Now I've used the word good in 3 statements. The first statement was clearly positive, the third statement was clearly negative, and the middle statement was neutral. However, if I'm doing superficial sentiment analysis, I'm only looking for words, and I pick the word good from all these 3 statements, I'll go back and tell the restaurant that you are doing just great. 100% of the people gave you great reviews. Okay, so sentiment analysis realizes that I can't work only with words, I have to work with expressions. And I have to sit down and go back to my old English grammar and do analysis of sentences and syntax. And then I also have to look at culturally, Indians use the word great and awesome much faster than, let's say, people from Japan or people from England. So if a global brand is getting a lot of awesome comments in India, but not getting so many awesome comments in UK. It's not because the UK guys haven't liked that product much. It's just that they don't use these big words too easily. They don't use the word brilliant for everything that they use, right? So people with sociology, psychology, anthropology backgrounds are coming into the teams that comprise sentiment analytics teams, which include mathematicians, business domain people. They include statisticians, technology people, but also people from the social sciences, because sentiment is not numbers. It's words, and it's culture, and it is background, and all of that. So it's really interesting, and but it's really tough, and I don't think data science has yet been able to master sentiment analysis. Okay, but a lot of effort is going in that direction, right? So I think this slide, when you get the presentation, I think have a look at this slide. I think it really gives you a good snapshot of historical, evolution of data, and how we have used data up to the big data place, or stage. And of course, people are already, I think, I'm sure they're going to talk about very big data very soon, right? So yeah, let's look at the next slide now. Right. So evolution in big data technologies helps businesses to enhance and streamline existing databases, uh, add insights to existing opportunities, explore and exploit new opportunities, and provide faster access to information. So we are not going to really discuss big data technologies today, but let me tell you, just give you a heads up, is that the way we store data is changing, and it's not just one different way of storing data. There are several ways now. The way we query data is changing, and as I said, SQL cannot be used in a lot of these cases. And the way we analyze data is changing, because with such large volumes of data, you have to go for massive massively parallel analysis processes. And Hadoop technology is Hadoop is a set of technologies that kind of addresses that, but there are other technologies coming in as well. And within Hadoop, there is the technique of MapReduce, which already people are saying is losing place to another technique called Spark. So it's moving really fast. As teachers, we are struggling to keep pace with new technologies, because the students always want the latest, and organizations are really struggling to adopt the new technologies, because by the time they understand one technique and technology, it's already obsolete. So we are waiting for a time when it plateaus down a little, and we can all breathe a little easier and say, okay, this is what is going to stay for at least a couple of years now. All right. But what is happening is exciting, complex, difficult, but you make more money if you manage more difficult things, isn't it? So that's why the best brains in the world today are moving towards analytics. It's a fact, right? Okay. So let's move. Yeah, so I think we've covered these. Allow storage of large volumes of information and allow faster. So we were talking about privacy. So maybe we should spend maybe 10 seconds more on this. Any questions on this? Because I'm not going to get into those technologies for two reasons. One is it's not part of introduction, and second reason, there are people who understand this better than I do. So I think we should hear it from them, right? So let's move to the. Oops. I'm having little trouble here. But the cost of collecting information on virtually every transaction or interaction falls to zero. The insights that we gain from our activity will fundamentally change the way we relate to one another, to institutions, and with the future itself. It's a book that I would strongly recommend. The Naked Future, What Happens in a World That Anticipates Your Every Move. It basically means that you are, this privacy thing. If you are connected to the net, and on your mobile phone, if you have said yes to, questions like, if you want this app, It'll ask for your location. So are you willing to share your location? And if you say yes, then you're pretty much naked because people know what you're doing, when you're doing it, how you're doing it, everything. And as you start wearing wearable devices, you know, you'll become even more naked in that sense. Okay, so that's what happens in a world that anticipates your every move. So you walk out of the house in the morning at 8:30 in the morning, people will know what you're going to do next. Okay. All right. Second knowledge check. A data-driven approach to decision making is not confined to only collecting data, but also to how the collecting data is being used in making crucial decisions. The approach here is mainly or is based mainly on, let me see if I can get them one by one. Oops, yeah, okay, this is good. Data and its analysis, experience, intuition, and data utilization. So which one would you guys pick? Yeah, anyone wants to attempt this? A. Yeah, the official answer is A, and we have to agree with this because it all depends on data and its analysis. But a quick discussion on intuition here. Do you think intuition is useless because you have all this data now? Anybody wants to address that? I mean, because data kind of contradicts intuition, right? That don't work with intuition, you have data. So why work with data? So is data kind of making intuition obsolete, useless, or is there still some place for intuition? That's right, Umesh. I think that's an excellent answer. I mean, if you don't have intuition about your business, you wouldn't know where and how to use analytics. So that's the first point. Intuition will drive the direction of analytics. There is another point, which is equally important. Anybody wants to hazard a guess on that? Yeah, I guess intuition is based on experience. I mean, unless you have experience, you don't have intuition in a particular business. So, Umesh, yeah. So, intuition is a function of intelligence and experience. That's how I describe it. And that intelligence is not something you feel every day. Uh, yeah. Uh, Devendra, I could utilize data in many ways, but it's the analysis, the richness of the analysis of the data that really works for me. Okay, but I see why you are saying utilization, because utilization could be the superset. If I do the right analysis, I'm utilizing the data better. So in this sense, these options sometimes become a little ambiguous. So I buy your point that data utilization is very important, provided within that utilization definition you also include analysis and correct analysis, right? And going back to intuition, the other place where intuition, or was that private? I didn't see that. Yeah, guys, I think Umesh has a good point. I think you should use the public uh, option to ask questions, so we can all learn. The point was that it's data utilization as the answer and not data and its analysis, and I was responding to that. Okay, yeah. So now going back to intuition, after you analyze and you get certain, what you do is, analytics is discovery. So you discover certain patterns. Now you need intuition to figure out what these patterns really mean. If you don't know anything about the business and you don't have experience of the business, then some of these patterns will not make sense to you. Okay, and I'll give you an example. The validity of which is now being questioned, but it's a very popular example in analytics. Walmart was trying to do some analysis, and they came up with this pattern that people who buy beer on weekends, Thursdays and Friday evenings, or sorry, people who buy diapers on Thursday, Friday evenings also buy beer. Lots of people who buy diapers also buy beer. They got that by analyzing invoices. Okay. Now, this sounds very weird. What is the connection between a diaper and a beer? But there were a couple of people who are old in this business, and they said that, hang on, a lot of people, working couples, young working couples, come to our stores on Thursday, Friday evenings to shop, and they buy diapers because they have kids. And because they have kids who have been in daycare situations, Mondays, Tuesdays, Thursdays, Wednesdays, where all the diaper part was being taken care of by the daycare centers, now that they have small kids and they're buying diapers, it means they're going to stay home on the weekends. Uh, Rahul, would you help Devendra on that, please? Uh, let me see. Okay, thanks. So I'm moving forward then. Yeah. So then they said that, okay, fine. So now that I'm going to be, we are going to be at home on the weekend anyway because we are taking care of our kids, then might as well also buy some beer. Okay. Now this is, this is related to your experience with running stores and looking at customers and just observation. And that's where intuition comes in. So intuition, as Umesh said, directs the path of your analytics, where you want to get into analytics, how you want to move forward, and intuition also helps you in interpreting results of analytics. So what did Walmart do after they figured this out? On Thursdays and Fridays, they bought the beer stack and the diaper stack closer to each other in their stores. And this was directed to those couples that were buying diapers but not buying beer. So then 60% of the couples who buy diapers also buy beer, 40% don't. So let us induce those 40%. So once they're buying diapers and they suddenly see the rack of beer, they'll say, oh, that's a good idea, let me pick up some beer as well, right? And hence, make more money, right? So intuition is important. If you know a business well, irrespective of how many data scientists you hire, your experience will always be valuable. Just that you have to bow down to the data. And if what you think about the business is contradicted by the data, I think you need to get into a debate with the data. Yeah. Rajiv, age is captured in some way. If you are paying by credit card or by loyalty cards, then they have a lot of, they have a lot of information, demographic information on these people. Uh, and Umesh, yes, once you start thinking couples staying back home to look after their kids, all these kind of ideas would also come to intelligent people in the store, and they would do things like that as well. So analytics leads to, so it's, finally the human mind that will make the best use of what the data is telling us. So that's a good example. Right. So let's move. Well, Pramod, we can't really measure that and draw a line. I think what must happen is a healthy debate between intuition and data, right? Because sometimes, as we discussed early in this session, sometimes what happens is that your data may be wrong, your metric may be wrong. You might have used the wrong analysis, and you might have got wrong results. And if your strong intuition about the business says that this cannot happen, I think there is time. There's time for a debate. But what usually happens, Pramod, is that the guy who has intuition and experience is usually the top guy in the organization. Okay, and if your data says something that he doesn't believe is true, he simply rejects that whole analysis and says that doesn't make sense, and that's a danger, because if you are going to get into data-driven decision making, you will have to look at data and you have to start believing data also. So a debate is always healthy, but end of the day, you can't really say that because my intuition says this data has to be wrong. Okay, so and it's also very organization specific. Some organizations give a lot of data because they have better techniques to handle data. They know their data is reliable. They have got into this journey earlier, so their data works and data rules. Certain organizations is just the opposite. Family businesses, we know what our business is like. We know we've been running it, blah blah blah. So if the data contradicts us, then data is wrong. Most of the organizations are somewhere in the middle. So as your analytics processes improve, I think people will go more and more with data, right? Yeah, Rajiv, that's right. We're getting a little ahead in our discussion, but it's absolutely correct. We've been using cameras all our lives to detect theft and stuff like that. But today, that same video footage is being looked at with enormous interest because it helps people understand shopping behavior. So there's a new domain of analytics called shopper analytics, which is different from consumer analytics. Okay, a shopper analytics is at the point of sale, at the point of shopping, how does the shopper behave? So how does the shopper walk through the store? Where does a shopper spend more time? How does it navigate the store just the way you navigate a website? Today I know how you navigate the store. It is helping people improve their layouts. Layouts have become dynamic. You know, Monday layout may not be the same as a Friday afternoon layout, may not be the same as a Sunday morning layout. Okay, where am I keeping my products? Old people products are now kept at eye level because there were certain images where they saw old people trying to reach a product and then just walking past because they can't bend, right? Something which sounds very logical, but when you have 1 million SKUs, you don't think about everything. But when you see it on a camera, you realize, oh my God, I had this bunch of products for senior citizens and they were at a lower shelf and I'm losing sales because the senior citizen cannot bend. He just tries to bend, looks at it, wants to inspect the product before buying, can't do that and just moves on. So absolutely right. Video analytics is becoming important. It's again very complex. How do you convert video footage into numbers and analyze it? But people are working on it, right? So, okay. So that's the right answer. Let's move to, right. So structuring of big data. Okay, let me see this comment before we move. Well, I agree with your first part, but intuition kind of, there is a lot of analysis already included in intuition. It's just that we don't realize it. I worked in Tata Steel with Rusi Modi for a brief while, and Rusi Modi always used to say that if people keep saying I have a lot of intuition, but it's actually the sigma of the experience I have. And I analyze that experience all the time without even realizing that, and that's what's intuition, right? So some of the analysis already kind of ensconced in intuition, and what I need analytics for is something that intuition cannot handle, because if things get very complex, intuition cannot handle it, right? If I'm a global player, if I have million SKUs, if I have thousands of types of customers, different types of people serving those customers, then intuition fails. So my intuition is restricted to my small experience, and it can't really stretch across everything. And then that's where I need data, and I use data. Okay, so data can be acquired from two types of sources: internal source and external source. So my internal source provides structured or organized data. External source provides unstructured or unorganized data. We already looked at this, and let's move. Oops. Yeah. So now this is also interesting because if you look at this screen, external business partners and syndicate data suppliers and internet. So I don't have I don't have an issue with internet and syndicate data suppliers, but the collaborative way in which companies work with business partners today, business partner data is kind of on the border between internal and external data, because the border of an organization is really amorphous today. Where does the organization end and external entities start? Because for example, a Marks and Spencer supplier has visibility to the Marks and Spencer store and its racks and where its own the merchandise is lying, so that Marks and Spencer's coming in, the supplier can actually uh, schedule its own manufacturing, looking at Marks and Spencer's offtake from its stores. So would you call that external data or internal data is debatable. But data suppliers, syndicate data suppliers data and internet data is obviously external, right? So these terms also have to be used with care. So I think we've been through this. So I'm going to kind of structured, unstructured, and semi-structured. Just to repeat, structured is organizational transaction data or customer data, which is in rows and columns. Unstructured data is social data, and semi-structured data is data given out by machines, smart machines mostly. Okay. Okay. So let's do a little bit more on structured data. Refers to the data organized in a specific format, resides in fixed fields within a record or file, has a format on which the entities and their attributes are mapped, and allows querying and reporting against predetermined data types. Right. So these are the things we are comfortable with and we've worked with all our lives. Okay. Uh, Relational databases, flat files, multidimensional databases, legacy databases. Right. So that's an easy structured data example. Okay. ID, name, product ID, city, and state. Let's look at unstructured data. Usually contains a lot of metadata, which is data about data, is not consistent across different records, can be from emails, text, audio, video, or image files. And some sources would be text internal to an organization, documents, logs, survey results, emails, data from social media, and mobile data, data such as text messages and location information. Right? Any questions on this? Seems pretty reasonable. Now we look at the challenges associated with unstructured data. It's a daunting task to derive any meaningful information out of unstructured data. It's difficult to convert unstructured into structured, and which is why the cost and time that is involved in analyzing unstructured data is far higher than the cost time involved in analyzing structured data. So why do people do that, right? And I think we discussed that right at the beginning of the class, because today organizations feel that all the time and all the money spent in analyzing unstructured data will give me actionable insights, and if I work on them intelligently, I will be able to make more money than the money I spent in analyzing this information. Which is why there is a huge move to try and get a handle on analyzing unstructured data. So since these are early days, different people have different approaches. What we are trying, what we foresee in the near future is that there will be, in the end, 2 or 3 techniques that will kind of become popular, kind of become, regular, and then everything will kind of settle down and we'll know, okay, fine, if it is unstructured data of this type, this is the way you analyze it. And if that happens, then you've seen it in IT, then the cost of doing that will keep on reducing, right? And today we have such a high demand for data scientists and business analytics professionals. Maybe 10 years, 15 years, 20 years from now, when things become more structured, there will be applications that will do most of the work. And so data scientists will work more on improving those applications than sitting in organizations and trying to do their own stuff, yeah, which is what has happened in IT as well. Okay, then Devendra, I think something wrong with your system then. Okay, great. Okay, great. Good to know that. Right. So coming back to unstructured data, so although it takes time and although it is not very precise right now, I think there will be a lot of efforts that will be made. And if you guys get into analytics, sometime in the near future, you will be working on unstructured data. I think that's pretty safe assumption actually. Okay. So and so there are a lot of PhDs happening in this space now, text analytics and all that. Right. So let's look at this graph. I think it gives you a lot of. Okay. This is a graph based on research with organizations, which talks about, what are the leading unstructured data challenges in percentage. And if you look at the different percentages, uh, data growth is the biggest challenge for about 20% of the organizations, and second most challenging for another maybe 12% of the organization, and third most challenging for, so like that. If you look at this, so the main challenges that people face nowadays are data growth, data infrastructure, because should you outsource that infrastructure? Should you, you know, uh, receive this entire analytics story through software as a service, or should you have your own, infrastructure? What should be your data policy, and how do you integrate structured and unstructured data? So all these are, you know, oh, x-axis is percentage, Umesh. 20%, 40%, 60% of the people of the organizations who were interviewed. So if you look at data growth, we just went through that. So if you look at these, data growth, data governance and data policy, very important again. And again, Indian organizations need to be careful, because we are very good at analyzing, but we are sometimes a little careless about data governance, and do we have a very clearly articulated data policy or not? Okay, and data policy includes things like, who is able to see what data, what kind of analysis is allowed and what kind of it is not allowed. Because if you are a healthcare organization, there are certain things about your customer which you may or may not be allowed to analyze. So is there a very clearly articulated data governance and data policy or not? And the organization needs to have that before it gets into analytics. Okay, integrating structured data with unstructured data to get better insights. Then of course, how quickly can I analyze this data, which is my data velocity. Variety of data would be kind of, I think, connected with data integration, because that's where the issues come. And data compliance regulation, if you are a bank, if you are a healthcare organization, or if you are, one of those organizations where regulation plays, if you're an educational organization, you have to comply with regulation. Any organization has to comply with certain regulations, but if your organization is in one of these sectors, then maybe the regulations are much higher. So, is your data policy and the way you access, store, and analyze data, is that in accordance with the regulation? You have to be very careful about that. And finally, so we haven't spoken about data visualization so far, but I think this is a good time to talk about it. Data visualization is an incredibly important part of data analytics. End of the day, you have either an internal or an external customer for whom you are doing all this analytics, right? And you need to be able to tell your story in a way that is easy to understand and which is also impactful, right? And data visualization is, we call that data visualization. So how can I make this data visually impactful and also, something that explains what is happening? And there is a lot of technology that is used for data visualization. So people talk about Tableau and ClickView and R, and companies like IBM have their own products. There are other companies that have their own products as well. Google has its own product. Now the question is, once you know how you want to do it, you'll find a tool. So the tool comes after you have decided that this is the way I want to. Of course, if you know the tool well, you also know how many ways you can present the same data. But I think your understanding of the business, your understanding of the audience, and your understanding of the business problem and its solution are the four more important things to determine what kind of visualization will you use for this particular story. Okay, but it's an area which is an area by itself. So there are companies and people who specialize in data visualization, right? So so there is science. It's kind of a mix of business knowledge, science, and creativity. And graphs look totally different today than they used to look earlier. So, okay. ABC is a retailer organization that conducts its business through e-commerce. The organization offers customized online shopping experience to their customers with an attractive and responsive web page user interface. Now the company wants to collect the data about customers' activities on the internet. What can be the best source for such data? So how many of you agree with Rajiv? Yeah, so I think pretty much everybody agrees, because when you are doing analytics, one thing is very clear. As long as you know that the data is valid, you should look at all sources of data, because the more data you have, more likely that you'll get something insightful out of it. So you don't shut data out unless, and let analytics tell you whether this data is relevant or not. Okay, so you'll need transactional database, you'll look at social media database, you'll also look at weblogs, and try and see what you can get out of it. So I guess that's the right answer, provided I can get the correct moving. Okay, now we talk about semi-structured data, because we talked about structured and unstructured. So now is the time to talk about semi-structured data. It refers to a type of data that falls between unstructured and structured, and does not follow a fixed structure of a data model, but has some structure. For this reason, it is called a schemaless or self-describing structure. So a weblog is a good example of this. Uh, Yeah, generally used to organize data into markup tags for separating semantic elements. So basically, for people who, I mean, get into these things, I mean, are you aware of markup tags as a group? Okay, so yeah, so okay, good. So if you look at the full form of HTML or XML, so hypertext markup language, or so when you talk about markup language, it is basically uh, how do I explain this? Because I'm not. I forget about being an expert, but I don't know how to explain markup. Can I just get back to you with that in maybe 10? Uh, Not necessarily, Devendra. It depends on what you are using it for. Okay, or what data are you transferring? So EDI data could be semi-structured, could be structured. For example, if you share an Excel sheet through an electronic data interface, then it's structured data. Okay. EDI is a technique to transfer data rather than a type of data, right? But we can look at, yeah. So as I was saying, a markup language, it has its own structure, but it does not have the flat file structure. It has its own. So I think that maybe I would, yeah, that's right. That's what I'm saying. XML and HTML. That these are examples of markup languages. But let me pass this for now and try and get a better explanation for this, which will help all of you. So let's park this for now, and I'll come back to you on this. Is that okay for all? Yeah. Okay. So now we move into the three V's of big data, and I have told you that when we come to this, I'll explain in some detail what these are. So volume, I think we all know that if there's huge volumes of data, then the existing technologies may not be able to manage it. Now, velocity is extremely important, and people are now moving to techniques where you can do streaming and analysis of streaming data. So I don't want to batch process data. I want to analyze data on a continual basis, which is where techniques like Spark are becoming important, right? So why does velocity help me? Because there are certain analyses that need to be done really quickly so that I can make use of that analysis to enhance my business or whatever that it is that I'm trying to do. And we talked briefly about location-based selling. So there's this concept of data obsolescence, and if my data is going to get obsolete really quickly, then I better be able to analyze it quicker and be able to come back with an insight which which is valid, and if I come back with that insight after the the validity time is over, then it has no value really. Okay, so that's why there is a lot of interest in trying to be able to analyze the data with great speed. Okay, and then variety again. Do I have the technique or the technology in place to get data from various sources and be able to utilize it? Now, the other two V's that people are talking about now, one is called veracity, which means truthfulness. So veracity of data is a very important thing, because is my data the right data? Okay, because if my data is not the right data, then anything that I do with it is going to lead me to wrong results. So is this, yeah, so Pramod, when you're getting data the first time, where are you getting it from? Is the source of that data reliable? That's very important. Okay, and how do I check the reliability of that data? Okay. And even within organizations, I mean, we had this. I worked with a large steel organization for a while early, and we had this whole discussion on, do we really know the cost of one pig iron block that comes out of that steel plant? And with all the data that is available, it's very difficult to you know to pin that down, because allocation of cost becomes a discussion in itself. Now, if you are going to do any analytics basis cost data, then you've got to be very clear that this is really the cost of this particular product. And it's not something that, is based on wrong analysis or based on allocation, yeah, and stuff like that. Yeah, Ravi, you have a point to make? Right, so let's move forward then. I think we've been through this. So yeah, so that was veracity. And then people are also talking about value. That's the fifth V of big data, because we have been doing data analysis for long. There's a very strong business intelligence practice in most large organizations and even medium-sized organizations. So it's not that this is the first time we are analyzing data and trying to get value out of it. But what we propose is that with big data, yeah, guys, can you confirm if you can hear me? Oh, yeah, okay. So yeah, so let's look at the value then. Rajiv, I think maybe you need to you need to check your system again. So what we propose is that never before have we had this kind of data. Never before have we had this technology to process this data. So the value that we can derive from this data is far, far higher than the value that we've ever been able to derive from data in the past. So the current five V's of big data are volume, velocity, variety, veracity, and value. Yeah. So with the enhancement in technology, companies are using different ways for marketing their products. The new sensors are being used with new marketing campaigns, and this results in new type of data and information. Which element of big data is being discussed here? So let's have a look at this. Any responses to that? New sensors are being used with new marketing campaigns, and this results in new type of data and information. Which element of big data is being discussed here? Mm-hmm. That's, yeah, Devendra, I got your answer. Any other answers? Yeah. So it pretty much gives it away, doesn't it? The new sensors are being used with new marketing campaigns, and this results in new type of data and information. So we are looking at new type of data, which means that, it kind of enhances the variety of data, and then I need to integrate it with the data that I have and get more insights, right? Okay. So let's move forward from here. But this is another interesting slide, and let's spend a little bit of time on this one. Where is big data analytics giving us a lot of benefit? Okay, and this is all based on research. So better social influencer marketing. So are you guys familiar with this term, social Yeah, I think the answer was variety, although on the screen you may have seen velocity, but I think that's a kind of a typo, but I think the answer should be variety. Yeah. So let's look at better social influencer marketing. So what is a social influencer marketing? Anyone? So do you want me to kind of take it forward then? It's not feed from Facebook, Umesh. Social influencer marketing is, uh, let's say let me take the example of Samsung, let's say, right? So I'm bringing out a new phone, and one of the ways I want to market my phone is to have a few people use my phone and talk about it. Okay. And so what do I do is I kind of, let's say globally, identify, let's say 10,000 people or 1,000 people, and I give that phone free of cost to these people, and their job is to use the phone and talk about it on the net. Now the question is, it's not beta testing, Umesh. We are not asking them to test the uh, phone. They're anyway going to use it. In that sense, you're right. But we want them to talk about it. So these are the kind of people. So maybe I give one phone to Amitabh Bachchan. You know, he has a lot of followers. He maybe I'm just assuming that he's into gizmos and stuff. So I tell Amitabh Bachchan, sir, you take this phone for free. You can tell people you got it free, okay? And yeah, Rahul, we can take a break. We can take a break right now or after this slide. Yeah, Pramod. Yeah, they need to post comments. They need to talk about it. Yeah, okay. So after this slide, we'll take the break. Yeah, that's right. So what you do is you use the phone and you tell people that Samsung gave me this phone free of cost, and I've been using it, and these are the things that I find great. These are the things that I don't find great. Okay. So now the thing is, how do I identify those 1,000 people all over the globe who are the best people to talk about my phone? Okay, so what are the things that I will look for? One is I look for the number of followers, obviously, but that may not be the only criterion, because I could have a lot of followers, but I may not be a very reliable guy. Or so they would scan my interactions on the net and the interactions with my group to find out what kind of a following does this person have, what kind of a trust equation does he have with his group. Uh, is he considered a techie or not? Do people listen to this guy or not? Does he have a lot of equity, and influence on people or not? Okay. So it could be a nurse who works in a hospital during the night and blogs during the day, who could be one of those 1,000 people. Okay. So that's social influence. And so if two companies, sure, Rahul, I'll let you make that announcement. Yeah. So what happens is that if there are two companies bringing out two mobile phones, if I get a better set of social influencers, I'll create a better buzz for my phone. So it becomes really, really important to get the right guys to talk about my phone, right? So this is why and analytics can help you, and there is a lot of very complex math involved in identifying your best social influencers. And so that is one. And then, of course, the rest of it I think are easy to follow. More accurate business insights, segmentation of customers, identifying sales and market opportunities, automated decisions for real-time processes. So how analytics can help is, how do I create? Yeah, they are absolutely, Umesh. They are brand ambassadors. They are brand ambassadors, but they are not brand ambassadors on television ads or on newsprint, but they are brand ambassadors on the social media. Absolutely right. That's who they are. But the fact is that I am investing in free phones and all of that, and I'm picking those guys, and the positive benefits of that could be very high if I pick the right people. Right? Okay. Right. So yeah, detection of fraud. So let's talk about that. Detection, or I think more than detection, big data analytics helps you prevent fraud. So if I'm a bank and I want to give a loan, then what kind, should I give a loan to this person or not? And today I can combine demographic data with social media data and then put an algorithm in place that tells me one of two things, yes or no. So the final thing that we do is something called logistic regression, which has either or, it's a 0-1 answer. So I can prevent fraud by better predicting behavior of the customer on what I yeah. So it's a little beyond BI, Umesh, because BI is pretty much more diagnostic and then trend analysis based on that. Whereas analytics can get into a lot of predictive things. Okay, yeah, right. Then quantification of risks, better planning and forecasting, and identifying cost drivers. So let's stop here for now, and I would invite Rahul to make his announcement, and then let's take a break for whatever 10-15 minutes that you guys want. So Rahul, all yours. And we could have 3 slides on this and still not do enough justice to all the areas that analytics can address. Let's now move to oops, 3 common analytical approaches. And as we move forward, we are revisiting this as well and looking at other things. So you look at predictive analytics, which is I mean, which is what, and of course we are today talking about prescriptive analytics also. That okay, so good, I can predict this. Now, what should I do now that I've predicted this? And that's called prescriptive analytics. So predictive analytics basically tries to predict the future, and if you can predict the future with a certain probability better than your competition, you should be able to make better business decisions than your competition. That's the assumption, right? And then there's something called behavioral analytics, where you get into complex data sets because these are mostly unstructured data, and try and understand consumer behavior. And finally, data interpretation, which is all the data that you've got out of your business. How do you interpret that business, and how do you make decisions based on that interpretation? Uh, this is a good time to actually look at the difference between business intelligence and analytics. Some experts say that analytics is a subset of intelligence, because basically what analytics gives us is more intelligence about our business than before. But then there is a set of people who say that these two are different, and analytics actually is a far more advanced domain than business intelligence. But let's have a look at what business intelligence is all about. It's more about describing the past. So let's say you are a seller of toothpaste, for want of any better product, or and can I do analysis on my past, let's say 2 years, 3 years, 4 years? How have my sales been region wise? How have my sales been size wise, size of toothpaste? How have my sales been vis-a-vis competition? And try and diagnose the reasons for which I may have lost market share in some areas and gained market share in some other regions. So basically, I am getting more intelligent about my business, and I am using data which is recorded traditional transactional data to get this intelligence. Using this intelligence, I could also do some trend analysis, saying that this is the way I've grown in the past. So if I draw a best fit straight line, then I should be doing this in the northern region, in the small towns. So I can go as deep and as fragmented as I want to. But typically, I'm looking at past data and trying to diagnose what went right with my business and what went wrong with my business and why. So obviously very useful. State-of-the-art business intelligence is, if I can process that data on a real-time basis, I can even describe the present and not just the past. Okay, but analytics says that I'm going to look at more kinds of data, and I'm going to assume that I don't really know much about my business. I'm going to put that data into a black box. I'm going to let algorithms analyze that data and then tell me what is happening in my business. Which is why we say that in analytics you discover rather than diagnose. And once I discover those patterns, on the basis of those patterns, I should be able to predict. Okay, so and business analytics looks at two things. It looks at predictive analytics, predict the future of individual records, and explanatory analytics, which explains the cause effect of average record. Okay, which means let me give you an example. Okay, let's go to the example. Yeah, individual. Yeah, I'm going to elaborate that. For example, suppose a bank wants to give you a loan, Rajiv. Okay, now the bank would like to give you a loan if they feel pretty much secure that you're going to repay it at the time that you're supposed to. So that is the prediction of the future of an individual record. Should I offer this loan to Rajiv or not? Explanatory analytics is what causes loan non-payment. Okay, so on the basis of trying to understand what causes loan non-repayment, I should be able to predict whether you are going to pay back the loan or not. So explanatory analytics helps me to understand the reasons for which people do not pay back loans, and predictive analytics for a future of an individual record is, will Rajiv pay back the loan or not? If the answer is no, I won't give you the loan. Is that clear? Okay, good. So let's look at an example that should be close to everybody's heart now. Flipkart. Now Flipkart, delivers under two conditions. One is cash on delivery, and the other is credit card payment. Now, suppose you log on to Flipkart and you say that, I want this particular product and I will pay cash on delivery. Flipkart is going to do very quick, complex analytics to come back to you and say whether they will offer this option to you or not. Because if you don't pay when they come and deliver that product to you, then not only is Flipkart, getting through the hassle and time and cost of getting that product to you, they also have to carry it back. So there is a reverse logistics expense as well. So they would like to have some idea of predicting the outcome of delivering on cash to you, right? And so what do they look for? They look for patterns. They look at patterns and they try to figure out whether, oops, will the customer pay. So that is trying to predict an individual record. What causes non-payment is trying to explain average consumer behavior. So it goes beyond income level and age and marital status and things like that. It also goes back to your history of transactions. It goes back to sometimes your geographical area. It could go back to things that that's what I meant, location. It could go back to what kind of industry you work with, because let's say the data that Flipkart has, for some strange reason, a lot of people who work in the railways have not, accepted goods and given them back. So I am not in a position to understand why, but my data tells me that if this guy is a railway employee, chances are, my data tells me that there's a 75% chance that he will not pay for this product. Okay, so that is the element of, although the data tells me this, I may not even understand why it tells me this, but if the data tells me this, I'll go by the data and not deliver on cash. Okay, so nothing against railway employees, it's just something that cropped up in my head, of course a completely weird example. But so this is where analytics wants to be. It wants to predict the future of individual outcomes. It also wants to explain behavior so that if I explain behavior better, I should be able to predict better. Right? So that's the, in a sense, the difference between business intelligence and analytics. Other important difference is that business intelligence is a pretty much structured process. You have a weekly report, you have a fortnightly report, you have a monthly report, you have very clear line items on this report. So when the management gets a BI report, they know exactly what will come every day to them. These will be the rows and columns. This is the data that I will get. These are the graphs that I will get. I also deal with maybe gigabytes of data, maximum terabytes of data when I'm doing business intelligence. When I'm doing predictive analytics, it's very ad hoc. It's almost like an experiment. Let's try and see what's happening in my food business. Yeah, is there something that is happening that I don't know of? So let's gather all the data and put it into the black box, do some data mining, and see if I can get some patterns. So it's ad hoc. The amount of the volume of data it uses is massive. Okay, and the insights it gets are usually for prediction and not for diagnosis. Okay, so this in a nutshell is the difference between business analytics and business intelligence. Any questions on this? Because this is a question that I face a lot of times from students, and sometimes our students are very critical that I don't want to get into a BI profile. I wanted to get into a business analytics profile. But in a lot of organizations, these two have not been separated to that extent. So basically, you join the BI team of an organization and they do analytics, or the other way around. So any questions on this? Okay, let's look at some example areas where big data has made an impact. As varied as transportation, education, travel, government, and some of this you will be seeing from your own experience. If you book something through Make My Trip, or even if you Yeah, I wish it were, Umesh. But this is far easier than actual predictive analytics actually. I mean, right? Yeah. Okay. So if you look at travel analytics, for example, you go to make my trip, and you don't even buy a ticket, but you just navigate and check up the fares on, let's say, fare from Delhi to Bombay a couple of times. Then, irrespective of the site that you visit, on the right corner, you will get best deals happening on, you know, Delhi to Bombay sector, hotel deals, flight deals, and all of that. So you might get irritated with that, but the fact is that at least they know that at some point in time in the recent past, you showed an interest in going to Bombay, either for yourself or for your friend or your family member. So in that sense, it's a far more targeted marketing effort than putting out an ad saying that we are flying from Bombay to Delhi to Bombay at such and such rates for the next 1 week, right? So, and then you look at sites like TripAdvisor. So today, if I'm going to a new city, and I don't know if you guys behave the same way, and if I'm not traveling on business, yeah, that's right. Yeah, absolutely. And sometimes it gets irritating because you wanted to go to Pushkar, you've already gone to Pushkar, you're done with it, and for the next 3 months you still get deals on Pushkar. And the probability that you'll go to Pushkar in the next 3 months is really, really low. Okay. And but you still keep getting. So I think this is all will get fine-tuned as people learn more and more. But also, I would go to TripAdvisor if I were going to a new city which I didn't know of and I was not traveling business. And I was traveling on personal, with family. I would go to a TripAdvisor and pretty much look up the reviews there. And based on the comments that people give on TripAdvisor, uh, hotels and airlines are customizing their offerings to suit a certain brand of customers. Okay, so that's how big data application can, it's about having a technique available. How best can you use it for your business? Okay, and if you look at government, I think governments are going to use this in a big way. US has a huge initiative in using. Uh, Rajiv, I'm not sure of that, but I think uh, people would be smarter than that. Even if you don't log in using your FB login, you probably still get suggestions. Yeah, yeah, yeah. It's Chrome and Google at work. Okay, so yeah, so coming back to yeah, absolutely. So coming back to governments, they I think they're going to be one of the biggest users of big data analytics in future, especially governments who have the right intent. Because you can really, they handle maximum amount of data, especially in terms of security and fraud and stuff like that. Also in terms of reaching out to all citizens with offerings and helping people, use the government offerings better, right? Yeah, Aadhaar-based payments. In fact, Aadhaar is a very interesting example because, Aadhaar had been written off when it was implemented. It was written off by the new people, but it has come back very strongly because it's data which is really useful and it makes sense to use it. Okay? But the trick here is that how much of that data do you use? How do you use it? For what purposes do you use it? Are you going to use it to get into my personal life, or are you only going to use it to give me, better benefits? Yeah, so these are those data privacy concerns that we all have because of analytics and the nature of analytics. Okay, so let's move forward. And I just took this slide because I thought it gave you one detailed analysis of, let's say, retail, because retail uses analytics in a big way. So you look at marketing, merchandising, operations, supply chain, new business models, and look at all the components of marketing: cross-selling, location-based marketing, in-store behavior analysis, customer micro-segmentation, uh, sentiment analysis, enhancing the multi-channel. So multi-channel means, I make a Titan watch. I can sell it through the World of Titan, which is my own branded showroom. I could sell it through a multi-branded showroom in a mall. I could show it through sell it through a Kirana store. I could sell it through Flipkart or through Snapdeal or through Amazon. So there are multiple channels available to me to sell my product. So how do I use big data analytics to pick the channels that I need to use, and how do I use them? Okay, uh, and then enhancing the multi-channel consumer experience. So it doesn't matter whether you come to me through any of these channels. Can I give you a consistent experience across all channels? Because the brand has to mean the same to you, irrespective of how you engage with it, right? Then merchandising, and we spoke about it. Assortment optimization depends heavily today on forecasting. So if my forecasting of demand of my million SKUs across 100,000 of stores is reasonably accurate, I could do a very good job of assortment optimization in each of my stores across the globe. This cannot be done through intuition. It cannot be done through any other method. It has to be done through pure data analytics and big data analytics. Okay, and then moving on to operations, uh, uh, performance uh, transparency means that across my organization and across my stores in the organization, do I know which of my products, which of my categories, which of my stores are performing better and which are performing worse, right? And then we move to supply chain inventory management, which I think is the heart of all well-managed organizations. Distribution and logistics optimization, informing supplier negotiations, and then moving on to new business models, right? So it touches each and every aspect of running a retail business, and analytics can be used. So if you look at retail analytics, it's actually divided into uh, marketing analytics, pricing analytics, HR analytics, assortment analytics. So all these have their own data that they look at, their own processing, their own techniques, and their own insights. And if you are armed with all these insights, you can do a far better job of growing your retail chain than ever before. Yeah. Any questions on this? Because this kind of gives you at a glance, what happens in the retail industry and how analytics can help you. Okay, let's forward. Let's one more question for all of you. You're the marketing head of an organization. You plan to increase your market outreach by converting prospective customers to actual customers. Everybody wants to do that. Which of the following analysis approaches would you consider as the best to adopt? Data interpretation, behavioral analytics, data visualization, data collection. Tell me. Oops. Yeah, Rajiv. Yeah. So yeah, I would agree with you guys. It will be behavioral analytics, because if you have a prospective customer and I want to convert you, then I need to understand some of your behavioral patterns, right? What works for you, what doesn't. Are you the kind of person who would like an email in his, a message on his mobile saying that this discount is on, or are you the kind of person who doesn't like that and stuff like that? So if I can have a handle on your behavior, I should be able to have a better chance of converting you from a prospective customer to an actual customer. So pretty much, that's what it is, right? Yeah, let's move forward. We have, I think, about 15-20 minutes. So yeah, so carriers in big data. So top 10 rated companies, this is about a year back, a year and a half back, so I don't know if anything has changed here. There are some really well-known names, and then there are some which are right, uh, which are not as well known, but they are pretty well known in the analytics domain. And if you look at people who are graduating from campuses, a lot of those, and we interact very closely with them. Obviously, we have our own. A lot of them, are pretty keen to work with smaller companies which are providing analytics services to the large companies, rather than working with large companies that are working on products or are working on analytics for themselves. So there is the community of people who are getting into this whole analytics game are pretty cool about taking risks, and they want to join smaller companies and learn more. Yeah, I've seen that trend, and not get lost in an ocean of a very large company. Of course, there are some who do, but it's an interesting thing to see, which I haven't seen in other domains. Sometimes in IT, but not as much as we see in analytics. So three really, yeah, these are the biggies, right? Yeah, three really clear areas in which you work: the data scientist, the data analyst, and the data developer, right? So if we move from right to left, a data developer is a techie, basically a techie, and instead of doing development on other platforms, the big data developer would be working on big data platforms, which typically today means the Hadoop ecosystem, right? And of course, there is a good requirement for such people today. But you remain a technology guy, and you remain you kind of get married to the whole development ecosystem. And then we have the data analyst, and then moving leftward we have the data scientist. So a data analyst is somebody who's comfortable with data, okay, and is kind of somebody whom a data scientist would give work to, that this is the data I want analyzed, this is the data that I want cleaned and organized and analyzed, and then you come back to me with what your analysis says. But a data scientist, which is the glamour word in the business of analytics, is a person who is accomplished in the three pillars. The first pillar is business, so you should understand the business. The second pillar is statistics and mathematics, mostly statistics. And the third pillar is technology. Okay? And the fourth pillar actually is communication, storytelling. Can you tell the story? So you need to have an understanding of the business, you need to have an understanding of statistics, statistical modeling, and you need to have an understanding of technology, the ecosystem, the tools. So if you are, you cannot be an expert in all three, obviously. You could be an expert in one, but be reasonably good in the other two. But unless you have an understanding of a working understanding of all three, you will struggle as a data scientist. Okay, so it's popularly said in California that a data scientist is a software engineering who knows more statistics than a common average software engineer, and a statistician who knows more software engineering than a regular statistician. Okay, and so that's how a data scientist is defined. So let's look at this in some detail, because there is a lot of So what is a data scientist? So if you look at this Venn diagram, you have programming or hacking skills, you have mathematics, statistics, and you have business domain knowledge. And data science is at the intersection of these three domains. If you have programming skills and mathematical skills, you are an expert at machine learning. And if you have mathematics and business knowledge skills, you become an expert in OR and OM. And if you have business domain and programming skills, you become a RDBMS, ERP, DW kind of an expert, right? But if you have all three of these, you become a data scientist. And if you look at the right side of the of your screen, the data science workflow starts with, actually starts with understanding the business problem, converting it into an analytics problem, and then moving forward to acquiring Cleaning data takes away 70-75% of your time. It's a very boring thing, but that's what it is. And then doing some analysis, and then disseminating whatever analysis you have done. And it's an iterative process because the more you analyze, the more insights you get, the more data you will get to do more. And it's as they say, it's always in beta stage. But then a time has to come where you have to make decisions based on this analysis. So it's an iterative process, but a company has to kind of take stock and say, okay, fine, we are pretty much clear about what's happening. Let's make this decision and let's move forward. Okay. Any questions on this? Right. Yeah, so let's look at the skills that you need to know. Okay. Big data professional should be an expert in technical and soft skills, introductory knowledge of certain languages, understanding of Hadoop, Hive, and MapReduce, knowledge of natural language processing. So let me tell you this thing, usually most people don't know all of this. Okay, so don't get scared away. So I mean, I'm yet to, and I've been in this for the last 5-6 years. I'm yet to meet a person who says that I know all this, right? Good to know, but eventually you would be very good at a few of these things, and you would understand most of the others well, and some probably will be outside your jurisdiction totally. Okay. Have a look at this slide and let me know if you have any questions. Yeah, okay, Rajiv, let me respond to that. If you are, never seen a DOS prompt in your life and you're, scared of writing a one-line code also, then, data science is going to be very, very tough. You can still be a business analyst where your, domain is statistics and statistic modeling. But the moment, even that is a little tough because the moment you start modeling large amounts of volumes of data, you will have to use some technique like R or SAS or Python. And the moment you start doing that, you'll have to do a little bit of programming. Okay, it's easy programming. It is very user-friendly programming. And as we move forward, I don't think there is, that there is any doubt that we'll have menu-driven software packages doing this as well. Yeah, Minitab does fit in. I mean, they haven't mentioned everything here. Minitab is, I think, more statistics than analytics. Although statistics is a part of analytics, but Minitab would fit in depending on the kind of analysis you are doing. Lindo would also fit in if you're doing a particular kind of analysis. So there are lots and lots of these tools. And as I said, the tool is not as important as what goes before you use the tool and what happens after you use the tool. Right? And yeah, and if you come to the second side, soft skills, strong written and verbal communication skills, and this is the first thing that people take lightly. But let me tell you, I mean, whether you're working with data science or analytics within your own organizations, offering it as a service to others, looking for a job in analytics and facing interviews, I mean, your ability to communicate, because these are complex things, you're trying to communicate to a client that last 5 years, some of the business decisions that the client took were wrong, and this is why they were wrong, and that's what the data tells you. Unless you can structure it properly, unless you can make it understandable by the user, it's going to be very difficult. You can't call up your customer and say your R square is 0.98. He's not going to understand what that means, right? So you have to explain the business implication of that and why what you're saying is right because of the techniques and the analysis that you use. So please, I can't emphasize it. I mean, we've had seen some really good students struggle to get good jobs and do good at those jobs because they lack this. So you got to work on this, right? And ability to advise senior management. I mean, senior management is willing to listen to you, provided you make sense to them, because they have very little time. So can I get my point across in the short time that I have, and make sense to the senior management, right? So any questions on this? Oops. Yeah, some industry numbers. Yeah, Umesh, that it's interesting what you say, and most of a lot of top management is not very comfortable, with reverse delegation. They don't want an upstart coming in telling them what to do with their business. Uh, it takes me back to when I graduated from college and computers were so scarce that sometimes you ended up teaching your boss or your top boss how to switch on a computer and how to log into a computer and how to write an not even an email but a text document. And you could sense that the boss doesn't like being taught that, but he has no option. So today, it is reverse delegation, but a smart boss will be happy to do this because eventually it will help him perform better. It's just that you have to pick the right people to delegate this to. So pick the wrong people, you are in trouble, right? Because you don't know enough. Okay, statistics, I think, again, depending on which side of the analytics part you're going to be, let me explain this to you. You could get into analytics if you have massive domain knowledge, and let's say, you are a rock star in healthcare and you spent your last 20 years in healthcare in various, advisory and operational roles, and somebody is starting an analytics initiative in healthcare, and as an offering, and doesn't know enough about the business, he could hire you, saying that I have the statistical and the technology knowledge, but I don't understand healthcare at the level at which you do. I don't have the contacts in the healthcare domain at the level at which you do. So I'll hire you purely for your domain knowledge. But as you work in my company, you have to pick up knowledge on statistics as well, or at least. So let me answer it in another way. At least you should know how to interpret results from an output. Okay, because if you can't interpret statistical results, you are pretty much lost. Whether you should be everybody in analytics, probably not. But if I give you an output and I tell you, these are the 4 results that this statistical analysis has given, you should have enough in-depth knowledge to say, okay, if this is what is happening, this is what it means for my business. Okay, but if you want to get into analytics and actually work in an analytics team and at an operational level, you need to know a lot about statistics. Okay, it's one of the most important pillars of data science because you're predicting, and predicting means there is a probability. Okay, and that comes through statistics. Okay. So look at these numbers. These are very healthy numbers. Lots and lots of people required with deep analytical skills, and India has 70% of the analytics business of the world because we are smart guys and we don't charge that high, right? Two reasons. So big scope, and it's not just about the scope, it's also about how interesting this whole thing is. You would love working in this field. So if you're working within an organization and you want to introduce analytics or an analytics approach in that organization, you would really be yeah, okay, Umesh, let me tell you, this range has become even, the range has reduced because this was predicted in 2010. So you're predicting 8 years hence, so there would be a range. Now the number is supposed to be even larger. Okay, and I think it's typical of a consultant to play a little safe as well. So, given all of that, I think 140,000 number is big enough. I mean, we don't even need to bother about the 190,000 number actually. Yeah. So, yeah. So let's move forward. This is what the ROCKS Big Data Analytics certification offers. The analyst certification track and the developer certification track. And if you see, there are some courses that are common to both. Yeah, and anyway, you will be going through the course, so I don't think we need to spend time on this one. Let's move to Sam is seeking a career as a data analyst. Which of these is a key requirement? Let's have a look at these. Determine what data means and recommend ways to search the data. Specialize in collecting data from different sources, organizing in suitable format and making analysis. Design, create, manage, and interpret large data sets to achieve business goals. Develop code and images to automate data reports. Well, you probably will have to do a lot of bunch of all this, but out of these four, as a data analyst, where do you fit the best? Uh, so why would you pick C? Any special reason? Is there a key word that asks you to pick C? Yeah, I think a couple of you have picked C because you looked at the business goals part of it, right? But when you were explaining the difference between a data scientist and a data analyst, I think one of the differences was that the data analyst pretty much lives with data, okay? At least in this definition. And it's the data scientist that looks at the bigger picture and the business and everything, right? So maybe start as a data analyst and then kind of evolve to the role of a data scientist. That probably explains the answer here, which is B. Yeah, any comments on that? Yeah, so let's move forward. I think we've already seen in our first slide that we shared this today, the way data is growing. And if you look at zettabytes, I think we were looking at about 45 zettabytes on the first, and I think it pretty much matches. So these two are and these are from different sources, so the numbers match. Yeah. Okay. So 75 to 80% of the data uh, analysis is done in India. And by 2015, these are 2014 slides, but I don't have the numbers to agree or disagree with this. But I know a lot of companies have a CXO where X is either D or A, is a chief data officer or a chief analytics officer. And this was a big debate about 3-4 years back that, how do you show a career path to somebody who gets into analytics? So this is the career path. You can head analytics in your organization, and it will be the chief internal consultant to the rest of the business. Yeah. If you look at adoption by industry, which is at the right corner, you look at retail is a big user, BFSI is another big, BFSI banking and financial services and insurance is another big user of analytics. So every area, sector will use analytics. Healthcare is massive, especially with wearable devices. And maybe in the next class, you will look at the business applications in some detail. Yeah. So that's kind of brings us to the end of what we wanted to discuss today. So I'll quickly take you through a recap. I'll just take you through this screens. Just let me know if you have any questions right now. Yeah, we just quick note on the semi-structured data. So, why is called semi-structured? I was a little struggling with that because you see, an RDBMS is structured. It has rows and columns that are predetermined. Whereas semi-structured data, if you do coding in HTML or something, you can define your, or especially XML, which is extensible markup language, you can pretty much define your structure. You can have let's say a person, a header with a tag saying person, and within that you can have an address tag. And as you move along, you put those tags, and the program recognizes where the tag started and where it ended. So this is the address of the person, and the next tag is the age of the person. And I can do that for one person and do something else for another person. So these tags are what make it semi-structured, because they tell me what this talks about. So it's not as free-flowing, let's say, as a Facebook post, but then it is not in a predetermined structured uh, format as, let's say, an RDBMS. So I hope that makes it a little clearer than what I was saying. So there is flexibility, but yet there is structure because there are these tags to tell you what this is about. Okay, so and hence semi-structured. Yeah. Okay. Oops, I missed a couple of your. Sorry, I missed a couple of your. Yeah. So let me just go back to one of the slides to tell you what BPS stands for. BPS basically stands for Business Process Services. And Rajiv, yes, the trainers will navigate you through the books. This is an explore. This is just an introductory session, and and then there is one session on business application, and then the real stuff will start. So I think it's an important session because at least you know what you are doing and why you are doing it before you start actually getting to do it. Yeah. Right. Umesh, I guess that one is a service offered to others, and the other is what you do for yourself. Yeah, makes sense. Yeah, so yeah, absolutely. So BPM service provider is basically a business process service that is providing to me, right? So that's how it works. And these are all, I mean, jargon. I mean, let's not, not, yeah. Well, you could go through these slides, again. I think there'll be a recording of this presentation. Rahul will confirm whether that will be there or not. And you can, use Google and good and uh, go through that. Yeah, Umesh, I think I did answer this question. I mean, if you look at, I think I'm not totally clear about what exactly is there in the groups, in the books, but I think Introduction to Big Data is also part of one of your books, right? And yeah, and as I said, this is introduction, and after that the real working, dirtying your hands and actually working on statistics and data mining will also happen. Yeah. So, any questions? I think we overshot by about 10 minutes. I'm sorry about that, but
Thank you, sir. Sir, this is Dr. Anuja
right,
here,
yeah,
joining in.
yeah. Hi. So I think a couple of questions that they have asked now, I think you would be a better person to answer them.
Yeah, sure,
Yep.
sure. I could see a lot of questions which are addressed towards the books and the learning management system. I'll address these questions.
Yeah.
I think the
Okay, thanks very much, guys. Thanks, ma'am. So I'm switching off because I have to get into another session very soon.
right,
Yep.
right, sir. Thank you so much. And if you have any questions for sir, we'll take on in the next session.
Okay. All right.
Right.
Yeah, that's right. Thanks very much. Yeah. Bye all. Yeah.
Now I change presenter. Yeah, welcome all. Now, this is Dr. Anuja. I am here to take you through. I'll take your 10 minutes. I know that this was an introductory session, but it was a little elaborate session as far as introduction is concerned. I hope you all enjoyed the session. I'll take another 10 minutes of yours to help you understand as to what we'll be doing in this program. uh, you have understood that this is a program where we are working towards getting into the professional diploma in business analytics, what we have talked about. uh, Careers and other things I'm not going to touch upon because professor has already elaborated too much on what is there for you when you actually take a big leap into this particular skill based program. And what we would now touch upon is that I could see there were a lot of questions on to as to how the whole system would work for you. I would take you through with that first. I'm sure most of you must have received your books. Uh, Yes, uh, I would appreciate if you could just type in the yes if you have received the books. Okay, those who haven't, I have a list of people who are still to be delivered books. Probably this week we should be able to do that. I think uh, Dash hasn't received it, but probably the next week he'll have it. Yes, for most of you, those who have received the books, you have seen that there are two sets of books that we have shared with you. And again, what we have also would be sharing with you is the learning management system. When I talk about the learning management system, we would be sharing with you the username password for it. That we have sent the request to activate it by today, by Tuesday. That should be activated because we wanted the whole batch to set in first. Now, when we are talking about the LMS, your LMS would look like this. Uh, you would have one course in your LMS, that is the professional business analytics course. And when you look into it, it would carry the complete analysis as to how many times did you log in and what was the time spent and what was the last date when you log in. These are the statistics which would help you also to be in the course and also help us as an admin panel to see to it how you're progressing in the course. Now, this course, as you can see to it, on the top of it, I hope all of you are able to see my screen. Uh, when I share with you, there is a tab here called content. In the content, we have as we have described, this course is divided into four modules. That is the module on introduction to big data, introduction to analytics and R programming. We have a course which would be actually taking you to the data analytics, data analysis using R, and also advanced analytics using SAS. Uh, the books for all the course have the hard copy of the books have already reached you. What you would be now getting is the LMS. As I was describing you the LMS has also been structured in the same manner. You would have the content. In the content, if you can see to it, we have the four modules that we are discussing are towards the bottom. We also have listed out the course introduction and FAQs related to it. When you view it, you would have the major questions which generally comes to a student mind when he is going through this particular course as such. And it more or less this particular handbook would help you to answer most of the questions. What you also, since we would be I'll take you to the first module, that is the big data fundamentals. In big data fundamentals you would have the pre-reading material. When you go to the pre-reading material, when say what all we would be there, when we view about this particular thing, you could see that a lot of information is already there. The pre-reading material, objective of the pre-reading material is that before joining in the class you go through it. This is advisable, not mandatory. So if a person comes prepared with these basic things, probably he is more into the class and understands what are the topics which would be covered in each of the classes. So you have we have a pre-reading material where we have the basic concepts of big data, business application of big data, technologies for handling big data, and understanding the Hadoop ecosystem. These are the topics which we have in our first module, and these have been put into very detailed. If you go through it, there would be slides on session objectives. Say for example, today we have taken this course in big data. We have the session objectives. Uh, uh, Actually, I wanted to show what here, what we are actually looking into. When we look into the big data introduction, in the big data introduction we have lot of other information added. There would be each of the session would have some of the video clips, which average time for each of these videos would vary from 7 to 8 minutes, but these are very informative videos which helps you to take on this course better. And I'm sure once you have taken this class, these all videos would add value to whatever you have studied here. Apart from the videos, we would have a lot of the other structured activities which would be taking you through the concepts. You would also have apart from this, there would be a test module for each of the session. You can take the test. This test would probably be ranging, may have questions from 1 to 5 questions. When you say you start a test, you can view the questions, and I'm sure by attending the first session you would be able to undergo this particular test. This consists of 5 questions. There is no negative marking as such. The objective of the whole exercise is to make you understand or rather make you revise whatever has been discussed in the classroom. Right, so every module, every class, after every session there would be a test which would help you to for step by step learning. As I was discussing, apart from the textbook, we would have lot of PDF files which are loaded here, which would help you to carry on with your course. These are all inbuilt into your first module. After the first module, end of the module, there would be a test. When you take on this particular test, you would as you can see, there would be 15 questions. As we progress to the next module, it is mandatory that you clear this inbuilt test for yourself, right? uh, I hope we are now all of you are clear as to what we have in our test. Uh, any question or what we talk about the LMS also? Are you clear with it? These are regarding the books and study material, right? Uh, in case you the access to LMS would start on Tuesday. Uh, Tuesday morning, we would be sharing with you the username password. Uh, Once you receive, you can update your profile in this also, and you can navigate the way that you want to do. Your LMS would help you to really guide as to what all you have covered and what is left. and we would advise go by the inbuilt instructions that would help you to take on the course better. Why? Because the way that we have designed the course, that LMS is supported by the online virtual classrooms that we are holding. So your faculty would also be in accessing these files, and they would be taking some of the information which is already inbuilt in the LMS, and a lot of things they would bring into the classroom through the interactions that they would be holding. And apart from this, what I would as we will move further, you will find that we are using two softwares here. That is the software for analysis. One is R, which is used here, and another is the SAS software. So what we would be doing is that this LMS has an inbuilt system by which you can download the various modules of R and also the SAS thing. In case you have SAS, we'll take on into the fourth module. So we would advise that once you're through with your first module, you download your R. We have used two modules of R here, the R console and the R studio. Both of them are inbuilt into your system. So your virtual classroom would be or virtual lab would be set for you, right? In case you have any problem at any point of time accessing this, we would be available. Rahul would always be available on emails. You can drop an email to me, or you can give me a call any of the working days if you have any of the issues regarding this. Now, when it I have a questions here. Any day by day schedule about the classes with the module? Yes. We would be sharing on Monday. I would be sharing you with the complete detail as to what are the topics we would be covering for the first module, how the classes would be scheduled, and the basic objective, everything would be shared with you. Along with that, what we are also going to share with you is the profile of the two trainers or which would be taking you through this course. So today you had interacted with one of our trainer, Dr. Charanpreet Singh. I'll give you a brief background of Dr. Singh. He is a BTech from IIT Kanpur and an MBA from University of Ohio, and he is an associate dean and is in the area of information technology and strategic management area. He's a champion into those areas, and he has been teaching the data analytics for almost 8 years now, because the whole concept is new. But when we talk about predictive analytics, which is now the in thing, but descriptive analytics has been there always. So he has been associated with his consultancy project with organization like British Oxygen, Tata Steels, PwC, HP, Compaq. With HP, he was in fact the country manager, and he has been a visiting faculty to IIM Lucknow and IIM Raipur and IIM Shillong. So you get lot of information and lot of learning he would be sharing in our virtual classroom. Uh, Yes, and the second professor for this course would be Dr. Prithvis Mukherjee. He is again a BTech from IIT Kanpur and an MS and PhD from University of Texas. He has around 25 years of experience in IT services. From corporate, he shifted to academia around 6 years back, and he has served with IIT Kharagpur as a professor, with IBM heading their global center, with PwC, with Tata Steel, NSDC, and he is a visiting professor to IIM Udaipur. So we'll share his complete profile of both of these trainers with you. And I myself, Dr. Anuja Pandey, would be your core faculty from Aima, who would be supporting you for the course during the weekdays. In any, if there is any challenge that you face with us, do write to us. You can reach out to me, and we would make sure, since we have been talking about that we want this course to be more interactive, and probably if you have any of the suggestions, we would really see to it that how we can incorporate these suggestions in our sessions. And as far as the things are concerned, apart from LMS, what you will receive every week is the recording of the session that was held on every Saturday, right? So you can go through the recordings. This revision exercise would help you to reinforce the basic concepts, and then the once we are actually doing the hands-on on the data analytics, these fundamentals that we are building in our first session are going to be really very useful. So and apart from that, if you have anything more that you would want me to share, you would just let me know. I'll like to take on the questions. uh, there's a question as to so that we can use pre-reading material before the class. Of course, the intent of pre-reading material is to sensitize you to the major concepts which would be covered. Idea and objective is that the learning has to be collaborative. Why? Because most of you are coming from industry, you are already experiencing a lot of things happening there. You need to correlate as to what is happening there. So this is the reason we say that we emphasize it is advisable that you come with going through the pre-reading material so that you are at a higher learning curve, because this is not a I mean, though we say this is a starter course, but we intend to make the learning more useful for you all. Yes, Umesh, will this course lead to IT certification or any diploma from Aima? Yes, you would be getting a professional diploma in business analytics from Aima. I'll do one thing. I'll just share with you the sample certificate. Uh, I hope, Umesh, you can see this sample certificate that you are going to get from Aima. Uh, this would actually be the. I'll just let me go through my slides a little further. Uh, this is the certificate that you will get from IMA, which would very clearly specify that this has been awarded to you. The professional diploma in business analytics has been awarded to you. The grading for these would also be there. Rajiv, let me take on your question. Uh, just a second. Rajiv, madam, I have no knowledge of any language, but I've done a domain expertise can prerequisite from an. No, Rajiv, you do not really need any kind of other support. We would be giving you all the support. When we would be introducing you to the R software, you will find that anybody who has used DOS, he'll be very comfortable with R. And R is basically a string based language. Most of the commonly used strings would already be built in. So when you go to the PPTs, you will find that the PPTs are designed such that they help you to write your commands. So there would be a lot of support which you are going to get from those pre-reading material and the slides which are there for you. So and of course there would be the professor guiding you on every Saturday. What we have also tried to do is that we would have some of the research scholar in this area to help you out with any of the tests that you are administering or you are struggling to really uh, put in your putting in place your software or other things. There would be support which would be on demand. Once you write to us, we would then probably fix up a timing with you so that he can help you out. Yeah, Umesh, on the lighter side, A plus would be shown in each module. Yeah, that in the sample, yes, this was, I mean, we were showing you a sample that every candidate would not get that. There would be grading, and grading would be based on, I would also take you, let me also help you to understand how the grading would be done. Well, as we had discussed here, uh, in this sample you have grading would be A plus. A minus, B plus, C kind of grading. That is a general system that we follow at IMA. And I would also let you understand as to how the assessment would be done. If you can see the slide, the assessment would be a modular assessment. And when I say modular assessment, based on the assignments and the project, which would carry a 50% weightage, and the final assessment, which would be carry a 50% weightage, where we would be conducting the online examination, which would cover the entire course, and the question would be more or less multiple choice, or maybe some of the situation based, the way that sir has used in one of your examples. So your modular assessment would be done by the faculty trainer concerned. So if say in this module we are using two of the faculties, so they would just do a assessment. You have online test also, and there would also be some of the assessment they would do on and see that you are into the course. So the final assessment would be the complete coverage of the course. Hope I have answered this question there. Uh, and what we would say that, yeah, if I take you to this particular slide, that would help you to understand as to what is all there in your resource list. So you have the printed books, where you have the reading material. We would see if you are not able to download the R or any of the SAS software, we would give you offline land environment where maybe we might share with you some of the pen drives in case it is not downloadable to any of the participant. Your online resource would have videos, study materials, which would be most pre-reading material and post-reading material. There would be lab exercises. There would, in your lab exercises, you would have a lot of data sets which would be there. We'll create a virtual lab environment. There would be assessments, and there would be project and case studies in each of the module, right? And it depends upon how well you actually use these resources. As we have talked about, that you have been shared the study guide, pre-reading material. The videos are for engagement and demonstration. The practical sessions would help you to get use the concept and apply the concepts, and the project detailed project work would give you the competency and probably confidence that you can handle any of those tasks which are there for you after you are through with this course. And the evaluation is made quite simple. Now, when it comes to the classes, as we have discussed during the enrollment time, every Saturday we'll hold the class. Ideally, the class is scheduled for 4 hours. We'll see to it that we'll start every day, every Saturday on 10 o'clock. And if the course is not too heavy, then we'll have the 4 hour class. Or if the participant find it is little too heavy, then in that case we'll have 3 hours or 3.5 hour class there. The total interaction that you would have, there we would be around 60 hours of online instructions, 20 hours of online recorded session, 20 hours of online lab or offline lab, the way that you want to use, and 20 hours of self learning, which would be in form of the projects. So in totality, this is a 135 hours program that we have designed. And anytime you have any problem, we Rahul would share with you these numbers. You can reach out to us any point of time. And what we would also like to emphasize that we want your experience to be a great learning. So anytime you struggle with any of the things, do write to us. We are open to improve those systems. Um, yes, you will get all the this particular slide also, you will get it. And probably what we'll also require, the slides which sir has shared, which would be in form of your recording. So I hope this would be an enjoyable course for you, and you gain maximum knowledge out of you. I wish all of you best of luck and congratulate you for joining this course. uh, we look forward to meet you again on next Saturday. in between, if you have any of the queries, just drop us a mail. And I would be now, if there is any further questions, do let me know about it. I think I am not. I think I am not getting any of the questions, so I presume most of you have enjoyed the session. Thank you all for joining. See you next week.